Welcome back to PAG Waste Management. We're back to talking about our gasifiers, Handbook for Biomass Downdraft Gasifier Engine Systems. Today we're starting on Chapter 6, and we'll start with a little introduction to gasifier fabrication and manufacture. So gasifier construction is a relatively simple task and can be accomplished in any well-equipped shop using basic sheet metal welding assembly techniques. Indeed, the task is so simple that it was possible for the countries of wartime Europe to construct almost 1 million gasifiers in just a few years in spite of wartime shortages. Nevertheless, a number of new materials and fabrication techniques have become available since World War II, and we shall call attention to these improvements in this discussion. According to Cobb, the construction of a small gasifier, including the purification system, does not require sophisticated equipment or highly skilled mechanics. It can be built in workshops comparable to the auto repair shops found in most third world countries. So, fabrication refers to the construction of a single gasifier for use for an experiment. Manufacture commences when one undertakes the construction of a number of identical units. A general discussion of drilling, welding, and assembly procedures pertinent to gasifier fabrication and manufacture is beyond the scope of this manual. Instead, we shall comment upon specific techniques of fabrication as well as the wide range of materials specifically applicable to gasifiers. So, materials for construction. Gasifiers are usually constructed from commercially available materials such as steel pipe, sheet, and plate. When choosing materials, one should, where possible, select those that are readily available and off-the-shelf equipment, materials that are available in bulk quantities. One should avoid exotic alloys, special shapes, and custom fabrication techniques that require large initial setup and tooling costs, except in cases where their use is justified. Smaller atmospheric pressure gasifiers require a minimum metal thickness of 20 gauge, with double thickness reinforcements extending a few centimeters, like 1 inch, around all fittings and fastenings. The maximum mild steel surface temperature is 480 degrees centigrade. Although the metal temperatures encountered in well-designed air gasifiers do not usually exceed the softening point of mild steel, certain stainless steels or inconel may give the extra temperature resistance necessary for critical areas such as the grate, hearth, or nozzles. Some of the mild steel components may suffer chemical corrosion in certain parts. Corrosion is likely to occur in areas where the water condenses or collects, since gasifier water often contains organic acids. Water collection is especially a problem in regions such as the upper magazine of Ember gasifiers, as well as in some wet scrubber systems. In these instances, the steel should be replaced by corrosion-resistant materials such as copper, brass, epoxy, or lined steel, or stainless steel as required. Stainless steel usually costs 2 or 3 times as much as mild steel and requires inert gas welding techniques. Copper and brass cost 5 times as much as mild steel, but can still be joined by brazing or hard soldering using an acetylene torch. Aluminum is particularly vulnerable to corrosion in alkaline environments, and its use should be avoided there. Some wartime gasifiers, particularly the stationary ones, contain massive but fragile fire brick insulation. We're fortunate today to have lightweight insulating materials based on spun aluminosilicate that are capable of withstanding temperatures of up to 1500 degrees centigrade, far beyond the requirements of gasifiers. The aluminosilicate insulation also offers many times the durability and heat flow resistance of fire brick at a fraction of the weight. It's relatively inexpensive and is available in a wide variety of forms. The 2 to 5 centimeter thick felt blankets and vacuum preformed cylinders are particularly recommended for insulating the reaction zone. Moldable ceramics that come in wet putty can be shaped to the corners and edges and are thus also very useful. Finally, plastics can be used in certain applications. Some plastic pipe will perform acceptably up to the boiling point of water, is more flexible than metal pipe, and will not corrode. Plastic liners, such as epoxy paints, can sometimes provide the corrosion resistance needed in critical areas, provided temperatures are not greater than 120 degrees centigrade. A gasifier built, so for this methods of construction, a gasifier is built much like a water heater, and the same methods of construction are used. The workshop should be equipped with tools for performing tasks such as shearing sheet metal, rolling cylinders and cones, drilling, riveting, grinding, painting, sawing, tube cutting, and pipe threading. An acetylene torch is valuable for cutting and welding tasks, but an arc welder is preferred for mild steel welding. When aluminum, stainless steel, or inconel is used, It'll be necessary to use either TIG, tungsten inert gas, or MIG, metal inert gas welding techniques. All seals must be made gas-tight. Threaded and welded fittings are preferred at all points, and exhaust pipe gaskets can be used if necessary. High-temperature anti-seize pipe dope should be used on all pipe joints. High-temperature applications will require ceramic, fiber, or asbestos gaskets. Silicone sealant is appropriate at temperatures below 300 degrees centigrade, and rubber or Vuitton O-rings and gaskets will perform excellently at room temperature. The system should be leak tested before initial startup as well as after modifications. Leak testing is accomplished by plugging the system and pressurizing it to 25 centimeters of water with a blower. A thick soap solution is applied to all fittings and joints, and they're checked for emerging soap bubbles. Leak testing should also be performed at a standard test and regular maintenance schedule. So, sizing and laying out the pipes. When designing a gasifier, it is important to keep the pressure drop in the system as small as possible. Because there are unavoidable pressure drops associated with the gasifier, the silicone separator and the cyclone separator and the cleanup system, it is very important to use adequately sized pipe. The pressure drop associated with standard runs of pipes is shown in the next figure. Engineering and Plumbing Handbook is also lists the pressure drops associated with pipe fittings, such as elbows and couplings. On the other hand, gas velocities within the pipes should be adequate so that the entrained solids will be conveyed to their proper point of removal, as shown in the next table, rather than deposited inside the pipe. When laying out pipe connections for gasifier systems, it's important to allow the various parts that may require cleaning or adjustment. It's recommended that new systems be assembled with a large number of pipe unions to facilitate cleaning out the pipes as well as future design modifications. In general, it's better to use the pipe T with a plug rather than an elbow to allow for instrument mounting and other additions at a later time. After a unit has been thoroughly tested and in production, such provisions can be omitted. So let's see here, 6.5 is instruments and controls. So in this chart 6.1, we have gas velocity requirements for conveying solids. The conveying velocities in pipes are dependent upon nature of the contaminant. Recommended minimum gas velocities are the following. So for smoke, fumes, and light dust, 10 meters per second. Dry medium density dust, sawdust, grain, 15 meters per second. And heavy dust, metal tourings, 25 meters per second. So you'll look at an engineering handbook and see what kind of size of the pipe you would need to achieve those velocities of gas. We'll stop there and we'll pick up next time. Thank you very much.